Okay, this is just a quick video on reference angles. Hopefully you had a chance to go to the trig functions of special angles activity in Desmos. This first slide asks you to warm up by moving angles near the points in the terminal rays of the circle. So we have these numbers, these purple points, and we're trying to figure out where they go. And intuitively, many students grab the 0 degrees and start here. And if you have, great. I completely understand if you want to put it up here because that's the way the clock goes. But in mathematics, 0 degrees is actually on the positive x-axis. And then we just organize things in order by smallest to largest. So 0 degrees was the smallest, 30 degrees goes here, which makes sense because it looks like it's about a 30-degree angle with the x-axis. And then comes 45, which creates a 45 right triangle. And then we hit 60, which will create this green triangle that has a 60-degree angle at the x with the positive x-axis. And then finally we pull the 90 in and we have our 90 degrees. So that's our warm-up on this one. The next slide asks you to drag and drop the angle measures now for the whole circle, not just for the first quadrant. And so it may be helpful, well, we remember 30 was here, but it might be helpful if you happen to run into an angle that you're not sure where it goes, like the slope 60 is okay. I happen to be grabbing the ones that I need. And then 45, okay, first quadrant I'm getting again, here's our 90-degree angle. And then 120 is 30 more than 90, and away we go. So you're going to basically pull these guys out. 240 is more than 180, so it's got to be down here somewhere. 270, oh, that's another 90-degree angle, and you get the idea behind it. But then I want you to kind of talk about what you notice about the red points, what do you notice about the blue points, and what do you notice about the green points. Hopefully you see some patterns here and can talk about those and speak to those. And then we want to understand what a radian is and a new way of measuring angles. So watch this animation. I think it does a really good job of helping explain why a semicircle has an arc of pi radians, and then all the way around the circle is 2 pi radians for our central angle. So watch that as many times as necessary to really understand where radians come from, circle of length r, and away we go. When you get to the next slide, you're going to be counting by pi over 2 radians. So if a semicircle, half the circle, has pi radians for its central angle, then it makes sense that the upper portion here will be pi over 2, half of a pi. And down here it will be 1.5 pi, so 3 pi over 2. And then 0 is also 2 pi, also known as that. A couple of ways that you can do that. You can do what I did and just grab the pencil tool and write with your stylus or with your trackpad, or you can use the tool that was already selected. If you want to type pi, it's just the actual letters pi. And then if we hit our slash key, our divide symbol, going back to our main function, and then put it over 2, that's the shortcut way for getting a pi divided by 2 or a pi over 2. And so next slide then, we're going to count the circle in radians by pi over 4. So if a semicircle has a central angle of pi, then when we split it into go ahead and grab that pencil here, 1, 2, 3, 4 equal pieces, then this is going to be a 1 pi over 4, a 2 pi over 4, and 2 pi over 4 is the same thing as pi over 2 we found a moment ago. This is 3 pi over 4. 4 pi over 4 is the same thing as pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4 is once again 2 pi. So you'll do the same thing with the pi over 3s. Now it's been split into 1, 2, 3 equal pieces. So count by pi over 3s, and then do the same for pi over 6s. And you'll notice that since these are all spaced pi over 6 apart, sorry, pi over 6 apart. Then the green ones are also pi over 6s, but they'll be simplified pi over 3s. And then finally, I want you to grab and move all of the radian measures throughout. So a pi over 3 is one of these 60-degree angles, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Drag and drop them where they should go. And that should give you a good feel for how radians work. And then again, comment to what you notice about the red points, the blue points, and the green points. And 1 through 8 slides should be enough to get a start on this. The next piece then is to actually do the assignment on, the radians and reference angles. So radians and reference angles, it's really important that you live in radians to understand where these come from and not to have to convert back and forth between degrees and radians. You may need to do that for a bit, just until your brain gets the hang of radians and how they work, but it can be cumbersome. So we would really prefer you just to embrace radians and understand how that fractional part of that circle is used. But we also need to know what a reference angle is. So anytime we go in the counterclockwise direction, we have positive angles. And anytime that we go in a negative or a clockwise direction, we're working with negative angles. So from the positive x-axis, that's always our initial ray, to our terminal ray, if we're going in a counterclockwise method, that's positive, and clockwise method is negative. When we want to talk about reference angles, we're always talking about where that angle is with respect to the positive, or not positive, but the x-axis itself. So this is our theta prime. That angle to the x-axis, always the x-axis, never the y, is what we're interested in. So if we're in quadrant 1, it stays in quadrant 1. But if it's in quadrant 2, then we always want to either subtract it from 180 if we're in degrees, or subtract it from pi to find out how far we would need to go to get to the x-axis. If our angle is bigger than 180 or pi, but smaller than 270 or 3 pi over 2, we're in quadrant 3. And again, we want to know what is its relationship with respect to the positive to the x-axis, not positive x-axis, but just to the x-axis. And so we're always either going to be, if we're in quadrant 2 or 3, adding or subtracting from 180 or pi. When we get to quadrant 4, we would be adding or subtracting from 360 or 2 pi to find out how far are we away from the x-axis. So for these problems, if you're in degrees, keep it in degrees. If you're in radians, keep your answer in radians. But sketch that angle in standard position and then tell me what it is. I want to know what angle measure it is and in which quadrant. So a 60-degree angle, all right, that's this dot right here. So I have an angle, a 60-degree angle in the first quadrant. And we label our quadrants with Roman numerals. 135 degrees is this point right, or this angle right here. So we've gone this far to get to 135 degrees. It's 45 beyond the 90, or 45 short of the 180. And so this is a 45-degree angle in quadrant 2. Because the quadrants go 1, 2, 3, and 4. Negative 45 means I'm going in the clockwise direction 45 degrees. So if I go clockwise 45 degrees, this is a 45-degree angle in quadrant 4, and so forth. So I want you to work your way through these. Let's do a couple in radians. And I think you're going to notice that the best part about radians is when we look at these, at least these special angles, 5 pi over 3 is going to simplify to a pi over 3 angle. And we can count by pi over 3s by splitting this circle into thirds and counting our way around. So we had 1, 2, 3, 4, 5, 6 of those thirds. And so if we count our way around, we'll be at 1, 2, 3, 4, 5 pi over 3 is right here. This is a pi over 3 reference angle in quadrant 4. If it's something like pi over 2, we found that was this angle, it's not going to make an angle with the x-axis, so we're going to just say that this is a pi over 2 on the y-axis. Those quadrantal angles will just be on an axis. But 7 pi over 6 is going to be a pi over 6, and we count by pi over 6 as 1, 2, 3, 4, 5, 6 pi over 6 makes sense, that's pi. 7 pi over 6 is this guy, and so this angle is going to be a pi over 6 in quadrant 3. If you can get this concept down early, it's going to help you a lot through the rest of the semester.